All right. Hi, guys. Thank you. Oh, thank you. I read something about having a logo for your project, and I had to do something, so this felt like the best thing to do. But yeah, thank you guys all for coming to my presentation. Whether you had to or you just felt like it, it's really nice to have you all here. And yeah, this is my final presentation on the project that I've been working on throughout the past 4 months for the summer as a summer 2022 intern on the RHODS team here at Red Hat. And my project involves leveraging MONAI and RHODS. I know that's a lot of acronyms, and I will get into what they mean in just a little bit after I tell you guys a little more about myself. So I was born and raised in Moscow, Russia. I am currently entering my senior year at Boston University. Super exciting. I will be receiving a dual degree in biomedical engineering and computer science, hopefully in a year. And my first introduction to Red Hat was actually through BU. It was last fall semester through the Red Hat Collaboratory Program. And I was working on a research project in adversarial machine learning, which was super interesting, learned a lot of things I definitely did not know anything about before, and has definitely helped me throughout this project as well. And at my university, I'm also involved in Girls Who Code. I am on e-board for that. And if any of you guys are familiar with the organization and you have that at your university, if you still go to school, you should definitely check them out. It's an awesome nonprofit organization, and yeah, National Oregon, we do great things, I promise. So definitely check it out. All right, so let's get into the actual gist of things. What is RHODS? RHODS is the Red Hat OpenShift data science team here at Red Hat. It is also a cloud service that gives data scientists and developers a powerful AI ML platform for building intelligent applications. Our main services include Jupyter Notebooks, source-to-image publishing methods, as well as GPU acceleration, which will be really important in this presentation today. And it's the team that I've been interning on this past summer, so I'm excited to tell you guys more about it. Next up, MONAI is the framework that I have been leveraging into RHODS as a DEM application. MONAI stands for Medical Open Network for AI. It started up as a collaboration between NVIDIA and King's College London, and it's an open source and open access data framework, which, as you can tell, is very similar, kind of has very similar motivation and feel to what Red Hat does with their with all of their code and all of their projects. MONAI is freely available, and it is community supported. It is PyTorch based also, and it is mainly used for deep learning and healthcare imaging. Some of the software that they provide includes the core MONAI platform and software, the MONAI label platform, which allows for segmentation in different imaging. So basically highlighting certain parts of a medical image. MONAI Deploy, which is their Deploy SDK, as well as MONAI Stream. Now, before I jump into what my project actually entails, I really want to get into how data science is present in healthcare and some of the different areas that where they intertwine the two fields. This is really important to me as not only a biomedical engineering student, but also someone who is really interested in the medical industry. And there's just so much of potential within the healthcare industry through data science and through automating different processes. So first, medical image analysis. This is a process that I have been using throughout this specific project that you'll get to see in just a little bit. Then drug discovery and design, predictive analytics in healthcare, tracking patient health, and virtual assistants. So these are just a few examples. And as you can see, it is already such a huge kind of field. And there are so many opportunities for data science to step in and not only automate things, but just make things more, I guess, faster and easier for us humans. And this is where RHODS steps in as a data science service. For my project, my main deliverable has been a demo application where MONAI acts as a framework in the backend, and then I use Streamlit as a web UI developing tool. Throughout this project, since I did start this project myself, and it wasn't one that I could join, unfortunately, I did quickly realize that it was incredibly important for me to create an easy to follow repo, not only to enable contribution, but also to keep all of my documentation and files organized for myself and for anyone on my team and anyone who wants to contribute later on. Lastly, my two other deliverables are tutorials, one for deploying applications through RHODS. I'm using this project demo application specifically in my tutorial. And the second is a tutorial for accessing the Streamlit add-on through RHODS internal. This has been super helpful for me, and I'm sure it will be for many other people who decide to use Streamlit and their development journey. You can find both of these tutorials on my GitHub, which I will link at the end of this presentation. There's also a learning path coming soon, also on the Streamlit add-on and how to access it through RHODS internal, which is super exciting. It should be coming out with the next RHODS release, so keep an eye out for that. All right, so healthcare, data science, blah, blah. Why should Red Hat care, and why should they be interested in my project? My project does a great job at demonstrating development tools and the process of web development for data scientists, specifically tools that are very easy to follow and focus mainly on the machine learning framework and not the user interface. So Streamlit is a great platform for very easy, basic UI development. Another goal that my project, I believe, accomplishes is promoting RHODS services such as the GPU add-on as well as the Streamlit add-on. I utilize both of these within my project, and they have been not only extremely helpful, but essential to creating an application like mine, and you will get to know why in a second. I also used a custom image created by my mentor, Guillaume, and customers of RHODS can also be either provided or make their own custom images, which include libraries such as, for example, mine had MONAI and Streamlit included, which made my life a lot easier and can do the same for a lot of data scientists. I know that Christina, who is another intern on the research team, has been working on creating custom images, so I will definitely be talking to her about potentially having a learning path on how to do so, which I think could be really helpful for our future customers. And the next point, which I personally believe is the biggest goal of mine throughout this project specifically, is expanding the RHODS client base, specifically into the healthcare industry. Again, I believe there's so much potential there, and I see a great, bright future for RHODS in healthcare, and I really hope to see that come to life eventually in the near future. And of course, in the classic spirit of Red Hat, providing more open source research opportunities for not only Red Hatters, but outside developers. And this is definitely something that I support. All right, so I've been talking about Streamlit quite a bit. What is it, and why did I choose to use Streamlit in my application? Again, open source. We love to see it. Open source application framework that allows data scientists to develop easy applications. It has a library component, which includes different features for specifically, again, data scientists. And it also has a Streamlit Cloud, which allows you to deploy an application, connect data sources, as well as share your application publicly or privately. And you may be wondering, why do we need RHODS if Streamlit is already so great? Streamlit can deploy my application. Streamlit can share it. I can keep it private. I can make it public. It has all of my data. Why would I need an outside source such as RHODS? I'm so glad you asked. There are three main features that RHODS provides that Streamlit simply is not able to support. The first being GPU support. Yes, you can deploy your application through Streamlit directly, but it does not support GPUs, unlike RHODS, and you will see why it is important specifically for machine learning-based applications. The next feature being development experience. This is definitely more of a comfort aspect, but the RHODS Streamlit add-on allows you to see the updates that you make in the user interface immediately after you make the changes, instead of having to reload your code and redeploy your application through Streamlit. So the process is just a lot faster and easier for the developer. The last, which I had mentioned in the previous slide, is custom images. Through the RHODS service, you can create custom images that can specify all the packages that you need in your project, and you will never have to do another pip install again, which again, just makes your life a lot easier. All right, it is now demo time. Most exciting part of the presentation. Feel free to scan the QR code. It will send you to the tutorial on my GitHub. But again, you absolutely don't have to. I will show you guys my GitHub right here. My pride and joy, this is the repository that I have created for my project. It has just a lot of documentation on stuff that I've been working on and the files contained in the repository. And to access the tutorial, you can just go under testing the application and follow this tutorial. Don't worry, there's a ton of screenshots. There's a screenshot for every step, so you'll not get lost. But for our first step, we'll just head to the OpenShift console, which some of you may be familiar with. It should look something like this, and then you will log in with your credentials. All right, so you can see I already made my demo, but I want to demonstrate how you can create your own project and deploy your own project within OpenShift. So you would have to head to the administrator view. Mine's already in it, but if yours isn't developer, make sure to switch it to administrator, and then you will create a project. Let's call mine Maria Final MONAI, sure. It is good practice to keep your display name the same as your, sorry, the same as your name for the project, just without any hyphens. And then for description, I'll just do demo and then create. You also can't use any capitals or spaces in your project name. All right, so now that we're in here, we will head to developer view, and then you should be in topology. You will then add a project, and since we're working in a GitHub repository, we will import from Git, and then paste your, that is not the URL. And then I will get my URL of my repository and paste it right here. It should automatically detect your import strategy, which for my project is a Docker file, so that is all right. You should check all of your options. These are all specified in the tutorial as well. And then your target port should be 8080, and you should not be able to change that. Then you will click create. And before your build is finished, make sure that you head to, oh, I don't know why I did that. To this view, and then to, all right, here you go, to actions. And then at the bottom of the menu, you will see edit deployment. This is a step that we will need to do to access a GPU that is located in our environment. So here you will go to line 129, resources, and do limits. NVIDIA.com/GPU. And then you will set that to 1, and then you will do the same for resources. All of this code you can copy and paste from the tutorial. And the reason we specify a limit, it would actually not let you save the YAML file without setting a limit, because you can't overcommit a GPU. So you have to specify that here. And then you'll click save. So our build is running. It will take quite some time. And there's actually a little caveat to this. We don't have a GPU currently available since RHODS had a little issue last week after a new release of OpenShift dedicated. So we will head to the application that we already deployed. Let's see that right here. Topology. So this is the application that I had deployed before. If you know that you have an environment that doesn't have a GPU, you can skip the step of editing the YAML file to add a GPU. I should probably specify that earlier, but we can now click. Oh, I've been sharing the wrong tab. Should have said. So in this topology view, this is the project that I had deployed before, and you can click this button right here once your build has been complete and you have a running pod, and then it will open up your project, in this case, my application. So again, this first page just has a brief overview, a feedback form, the GitHub repository. We have a MONAI page, open source contribution, and then other pages on the side right here. As you can see, if you attended my last presentation, someone asked about the HIPAA violation and how do we avoid that. I actually added a kind of guideline and a privacy rule description right here, just to make sure that the user knows what they are and aren't allowed to do. Luckily, this is just a demo application, so it's not going to be used by real data scientists or medical research assistants. So you can just click agree and it will give you access to the application. You can share your images for open source contribution. You can process your images. Let's try this right here. So I have an image of, let's do a hand scan. And once you upload your image, you can select a sigma value. So the higher the sigma value in the Gaussian filter, the blurrier the image would be. So we'll set that to, let's say 0.11, sure. And you'll click to process. Beautiful. You can save the image if you want. So where does the GPU come in? Everything is working fine. Why am I complaining? Why are we struggling? In the classification page, the registration page, the segmentation page, all of those pages actually require a GPU, meaning that if I try to run the process right now, actually, let's do that. Let's do that in classification. All right, so I'll click I'll agree, and then I will find the image I want to classify. Let's say it's the hand, and then I will click here to classify. There you go. So we get the error that we don't have a GPU, so there was no NVIDIA driver found in the system. Unfortunately, there's nothing we can do about this at this time, but I have filmed a demo of my application working through the Jupyter Notebook environment, so I will post that later. But good note, make sure that your system is not failing before you do a demo. All right, back to my presentation. Sorry, that was such a roller coaster. Let's see what the other capabilities would have been if we were able to access a GPU. So the classification page simply classifies your input image as one of 6 labels. There's hand, CT, head CT, X-ray, and other scans. You also have a segmentation feature, which basically segments your image and highlights the required areas of anatomy. For example, in my application, you can do a liver segmentation, and there you will upload a series of files instead of just one image, because the series of files will be slices. So when your body's scanned, you basically have a bunch of slices at a certain increment. Super cool, a very interesting process. And that was probably the most complicated model out of all of these, which is why I didn't even load on the page. And then registration will just rotate your image into the common frame of graph. Okay, so we saw what needing a GPU can do. We saw how complicated it can be. We know that our life would probably be a lot easier if we didn't need one at all. But at the heart of machine learning is the demand to input large continuous data, which expands and refines what the algorithm can do. And the more data you have, the more accurate the algorithm is. So in a medical application like this, there is a ton of data. And if we were to rely on a CPU, I don't think a half-hour presentation would be enough time for that. So unfortunately, we weren't able to see those processes today, but hopefully I'll at a later time. So what's next? Since a big goal of this project is to potentially expand the client base into healthcare and biotech companies and fields, starting off with a blog post or an article about this demonstration, about this application, I think would be very useful, specifically talking about how RHODS was used within this project and how custom images can be applied into medicine and healthcare related data science projects. Another thing is workshops. So getting a company to demo to, or just a group of data scientists that do research in the healthcare industry, and showing this workshop to them when it works would be a great next step to expansion, hopefully. And lastly, conferences, I believe would be a great addition to once this whole project is finalized. So enough talk about MONAI and RHODS. There also have been some other projects that I've been lucky to be involved in this summer. The first being the IEEE equipment failure projection. This is another RHODS project led by Audrey Resnick, which was probably the most exciting project that I've been involved in this summer. My role was basically to document the process on GitHub, make sure that their repository looks complete and everything is well organized, and write up the workshop instructions similarly to how I wrote the instructions for this workshop in my repository. The other project I already mentioned is a learning path for accessing the Streamlit add-on. The draft is ready for review, and hopefully in next release we'll have that new learning path in it. And lastly, this has not happened yet, but the DevConf is coming up next week. I will be volunteering all 4 days of the conference. And if you happen to be in Boston next week during that time, that is Wednesday through Saturday, please do stop by. It is at Boston University. You can register by using the link here. I will add the slides to the spreadsheet later. It is super exciting. A lot of talk about open source, open data, Red Hat, and all of that fun stuff. All right, lastly, I want to share some resources with you guys, my GitHub repository mainly, that contains everything you need to know about my project, documentation for MONAI and Streamlit, both of which have been incredible resources throughout my journey. How to use RHODS with GPUs, which is probably the most relevant resource for today's presentation, as we saw what can go wrong if you don't have a GPU. So that is super exciting. And as well as the RHODS internal deployment page, which leads you to access the OpenShift dedicated page where you can actually deploy your application. And with that, I would like to thank everyone. I would like to thank specifically the RHODS team who have been with me throughout this whole summer. They've definitely taught me an incredible amount, and I'm so thankful for this whole experience. My technical mentor, Guillaume, my early talent mentor, Holly, our amazing manager, Heidi, and all of my fellow interns who have kept me inspired and motivated throughout the summer. And I also want to use this opportunity to remind you guys that I will personally not be stopping research or contribution to either this project or the IEEE project. it is really important to remember that even though our internships are coming to an end, Red Hat, the beauty of it is your end date does not actually define your end date. You can keep working on all of the open source projects that Red Hat has available. And I think that is definitely something very unique about this company. Yeah, if you guys have any questions at this time, I know there's not much time, but I will gladly take those now. I see some questions in the comments. When would you add more noise? So for the image that I use, none of the images that I have available to me are very good resolution. So you could see that even with that image, the edges were still kind of blurry with the low sigma value. However, if you have a very high resolution image and you don't necessarily need the full resolution in the converted image, you can decrease the sigma and it will save you some space.
I just want to congratulate you on gracefully conducting a very challenging live demo, Maria. That was very good.
Thank you. I've been trying to figure out. I've been bugging Troy actually, who said something in the chat about finding a GPU. I was like, where can I get one? Yes, RHODS does indeed only have one GPU. That is very hard to.
Yeah, that's crazy. That's crazy. We should be getting more GPUs into the Mass Open Cloud. So
that'd be great.
Thanks a lot. That was great.
Thank you guys so much. Yes, Christina, I would love to collab as well. That'd be great. Thank you guys. If there's no more questions, I'll stop sharing.